You are listening to Kubernetes Bytes, a podcast bringing you the latest from the world of cloud-native data management. My name is Ryan Wallner, and I'm joined by Bhavin Shah, coming to you from Boston, Massachusetts. We'll be sharing our thoughts on recent cloud-native news and talking to industry experts about their experiences and challenges managing the wealth of data in today's cloud-native ecosystem.
Good morning, good afternoon, and good evening, wherever you are. We're coming to you I'm coming to you from Boston, Massachusetts today, and Bhavin out in California. Today is December 7th, 2021. Hope everyone is doing well and staying safe. Let's dive into it. So I guess that's a good place to start, Bhavin. Let's tell everyone why you're out in California and what you've been up to.
Yeah, so a quick recap. Like last week was AWS reInvent. I was on the show floor working the Portworx booth. Had a lot of fun. Had a lot of great conversations, and because of that, I have my AirPods and not my regular microphone. So I apologize if this sounds terrible. We'll fix it. Like we'll make sure I have the proper gear next time around if we travel. But yeah, this week I'm in California in our Pure Storage office in Mountain View. This is the first time after getting hired by Portworx/Pure Storage that I've been in person in an office. It feels weird. Like I didn't see many people there. Obviously, it was just our team, the marketing team. But being in the same room for a meeting and having to look around while people are talking instead of just staring at a screen is definitely weird. So I'll get over it today.
Yeah, that's true. The world is definitely a bit different, but I'm super excited you're out there, everybody. And didn't you go to some national park again? Since you do that often? Yes.
Yeah, so I had the weekend between reInvent and the California trip, and I was like, okay, what's the closest one that I can go to? And Zion National Park in Utah was, I think, the closest, 2.5 hours away from Vegas, and it was the perfect weather. Like it's December, the crowds are not there. They even closed the shuttle, so you can drive your own car through the park. It's absolutely scenic. Me and my wife, I think, ended up doing around 18 miles of hiking in just 2 days. So like we were like super excited, super pumped, and now we are super tired. So,
probably.
Yeah, but it was a great weekend. Like really enjoyed it.
That's amazing. I'm super jealous. I've never been there. Hope to get out there one day soon. But
next Vegas conference.
There you go. The next Vegas. Again, since like the last episode, I've never been to a reInvent, so we'll just double down. We'll go.
Yeah.
I've been to the Grand Canyon and been to Las Vegas. Just haven't been to those two things.
Yeah.
I haven't had nearly the as eventful as a week or weekend as you had. I did go down and cut down a Christmas tree with my family this weekend.
Oh, nice!
Which is always fun. And this year, I feel like I was treated because it was very like, this one's perfect. Let's just cut it down. It didn't take 2 hours. We didn't have to go to multiple farms. Like it's always a whole deal for the most part. But this year was very seamless, and I really do appreciate that. And if there's any other dads and families that cuts down trees, I think you probably sympathize a little bit. It can be quite daunting for whatever reason to go find a Christmas tree. But
so what's the next step? Like, is it all set up? Is it all decorated?
Yeah, we bring it home. We put it. I put it in water right away. Do a fresh cut because we custom make a ornament out of the tree stump every year. So we have basically like a history of all our trees, and we write something on it. Like last year, it was something about the pandemic, kind of cheeky, that we wrote on there, and we laminate it. Not laminate it. We lacquer it now, all the stuff, and make it kind of last a long time. So. It's all decorated now. We do a whole family thing. We have a family tradition of that started with my wife's family. That they basically eat a bunch of junk food and decorate the tree, and so I can get down with that. And it's always a good time. But that's what I've been up to. There's been a lot going on in the ecosystem, though. I think we should jump over to that. Why don't we start with some of the news out of reInvent that you have here?
Yeah, reInvent is always a fun time, right? Busy news week. Again, there were like so many announcements, but we'll just focus on Kubernetes and maybe a bit of storage. But that's it. Like we are not here to cover the whole recap for AWS reInvent. The first thing, let's just kick it off, right? The first thing was AWS Marketplace for containers anywhere. So now, since AWS is talking about hybrid cloud and with their EKS Anywhere or EKS on Outposts offering, they are extending their marketplace offering. So vendors can now have validated and certified offerings on this new marketplace, which have been tested and validated for those hybrid use cases. So I can buy a license from, or I can subscribe to the solution from AWS Marketplace and get integrated billing, flexible payment options, longer term contracts, all of the goodness of AWS Marketplace, but for my on-prem workloads as well. And if I move it to AWS, I can still reuse the same license. So it definitely supports the migration use case between on-prem and AWS.
Interesting.
Second thing that I wanted to highlight was pull through cache repository for ECR. So all of us use Docker Hub, and if you don't have like an enterprise account, we know that there are limits that you hit uh, when you try to pull a lot of images continuously. Now you can have images pulled down to ECR, and you get benefits like the image scanning feature that ECR has, the IAM and KMS integrations that ECR has for all the images that you're pulling from public repos. You can also use AWS private links, so like you're not pulling down images from the internet, like you're still pulling it down from a secure source. So uh, that was another interesting thing that I came across. The third thing was AWS Carpenter. So when I first about heard about this, I thought this was a brand new announcement. But then when I like read up on it and looked at a couple of demos, I realized okay, AWS has been talking about it for the past year, and they also included a demo around Carpenter during KubeCon in October. But now they say that Carpenter is production ready. What is Carpenter? Carpenter is an open source and flexible Kubernetes cluster autoscaler. So if you start deploying pods which don't have enough capacity on your EC2 instances that are part of your EKS cluster, Carpenter can create new EC2 instances, add it to your EKS cluster, and then provision the pod. And all of this happens in a matter of seconds. So if you have a new pod that needs a GPU, or if you have a pod that needs that wants to run on the new Graviton processor based EC2 instances by using labels, you can just your developers can just deploy those, and Carpenter on the backend will create those EC2 instances, add it to your cluster, and then schedule those pods on it. So like Carpenter is super cool. You can start using it in production today. That was the main highlight. Like, okay, Carpenter is ready for everybody to use it, and it's not just an open source project that we are still trying to figure out what it can and can't do. But yeah, those are like some of the key ones from a keynote that I virtually attended that Werner Vogel does. A good takeaway on the New Stack blog was the 6 rules for good API design. And again, as part of the video, Werner does go through the fact that since AWS teams are so customer driven and customer focused, all of them basically follow customer requirements to design APIs, and there is no central way AWS does APIs, which is great for individual services. But if I'm a developer who's trying to use all like 10 different AWS services, I have to use and learn about how each of those APIs have been defined for individual services. So now, Werner listed 6 different design principles that everybody should follow. And these are actually good. Like things like APIs are forever. So make sure that you design them in such a way. Never break backward compatibility. So even if you keep adding new features, make sure you support it, because like AWS, right? Vendors do build on those APIs, and if you change anything and if you break backward compatibility, there will be business impacts for your customers. So if you're creating new APIs, make sure that, or you're adding new features, make sure you don't break backward compatibility. The third one was work backwards from customer use cases. So, like, identify what the customers are actually want to do with this, and not just assume internally because your use case might be different from actual customer use cases. Make sure you have good documentation. The APIs are self-describing, so like it shouldn't like the verbs that you actually use should have some meaning that is easily interpretable for users. Create explicit failure modes, and then avoid leaking implementation details at all costs. So like these are good design principles to follow when designing your own APIs. So do check out that keynote, and we'll link to the New Stack article in our show notes as well. And just three more, and then we'll hand it over to Ryan. So enhancements around EBS. So now you have a new recycle bin functionality for EBS snapshot. So organizations do delete snapshots when they see a huge amount on your monthly bill. Now, Recycle Bin adds that extra layer of protection, so you don't accidentally delete a snapshot that you didn't want to. You can move it to the Recycle Bin and see if anybody complains, and then you can restore from it if needed. Another enhancement around EBS was EBS Snapshot Archive. So if you want to keep that snapshot around for longer without paying a lot for it, you can basically archive it into a lower cost storage tier and have that EBS snapshot live forever. And then the last one around storage was around S3 Glacier. So what we have known about Glacier is, okay, it's perfect for archival, but it takes a lot of time to recover from a Glacier snapshot. Now they introduced a new class of S3 called S3 Glacier Instant Retrieval Storage class, which basically means that instead of waiting 4 to 5 hours to retrieve anything from Glacier, you can retrieve these things from Glacier in a matter of few seconds to a minute. And obviously it comes with a different cost with itself, but it definitely opens up certain use cases for vendors like us. So I think that's it for me from reinvent and backup. Ryan, what about you? Like you were here focusing on Kubernetes. What do you have for us?
Yeah, no, one that I did want to call out is the sort of new EBS snapshot capability to use that storage, which, if you're a listener of the show, a lot of these DR and backup scenarios you have on Kubernetes, you have to take lots of snapshots. And those aren't always the cheapest, types of storage, especially in AWS, to sort of leave sitting around. So optimizing those, Bhavin, you did a blog on how to optimize those based on the type of snapshots and how many replicas, get used on the cluster. And, the EBS kind of tier for long-term storage allows you to kind of offload to that Glacier piece, which is, often something maybe overlooked at first, but definitely as you start growing and you're like, wow, all these snapshots are really adding up, I know it will be something to look at. So definitely something interesting there. I didn't get a chance to look at Carpenter, but that looks really interesting. The fact that it looks at pods that are trying to be scheduled inherently has me question, why are we looking at things why are we failing to do that in the first place? It seems like Carpenter is a great use case for some kind of AI to tap into, maybe a DevOps tool to say, these are the things that are going to be scheduled, not just I've scheduled them and they can't be scheduled. So then we go just in time, kind of take it to the next step. But really,
like following up on Carpenter, right? Like one of the good things is it allows you to leverage spot instances. Like if you have workloads that like are sporadic in nature and can be used with spot, you can just specify the tag and it will try to provision EC2 instances from the spot pool that's available in your region. And so you don't have to pay as much for the same compute.
Yeah, that makes sense. Really cool tool, though. I'm going to go definitely click on the link you put in here. That we'll put in the show notes as well and listen to it myself. For me, a little more on this later, but this will be the last show of 2021. Big news there. We'll dig into it a little bit more at the end of the episode. But Kubernetes 1.23 is slated to come out, I believe, next week. And there's a lot of things volume related in there. And I just wanted to touch on those, in terms of how your applications are being used. So one of them is the auto remove PVCs function created by StatefulSet. It allows you to kind of set this volume clean retention policy within the StatefulSet, and allows you to, when deleted and when scaled, to do certain things with volumes. Definitely something that gives you a little more control over how that works. There's been a lot of work on the recovering from resize failures. Now, resizing your volumes is something that is probably fairly new in the industry, but the way to automate that and letting Kubernetes resize things under the covers as your application grows. If you have a failure during that scenario, you're in this weird spot, right, where your volume is going to be stuck in a weird state, or possibly it's not supported. And this has gone from graduating. This has graduated to alpha, which is recovering from resize failures, and really focuses on the enhancements around users reducing a PVC size as well. If that happens to fail. So really cool stuff there. I know at our day job that comes really into play with a lot of our automation as well. So definitely taking a look at those. Honoring reclaiming policies, another one. I'm not going to go into every one of these. Non-recursive volume ownership for the file system group. There's you can config FS group policy in CSI. So there's a lot of changes in CSI as well. I think there's like 20 or so here. But definitely take a look at the notes for 123 in regards to storage and things like that. I know Windows privileged containers, things like that is graduating to beta. So lots of good stuff in there. We won't necessarily cover it probably because we're going to be into January by the time we have a next episode. So I want to make sure and link to an early article from SysDig that came out and talk about it.
Yeah, I need to read up on that too. 1.23 sounds exciting.
It does. So without further ado, though, we will jump in today's episode. We do not have a guest for today. Today's episode is really focused on Kubernetes objects. We'll talk about what they are and which ones actually use storage. So I think this kind of takes a step back and looks back towards that 101 level of conversation that often gets overlooked, I think. So we wanted to spend some time that to really dig in to what are those objects. Maybe we can even provide a list here, and which ones use storage, how they differ, which ones use storage classes. We covered sort of storage 101, but we didn't really dig into each individual thing here because we often deal with deployments and StatefulSets, which we talk about, but there are a lot of things in that in the Kubernetes ecosystem that uses storage. So I think a good place to start is, what is a Kubernetes object? We'll start there to say, because we're going to talk about Kubernetes objects that use storage, let's start there. Now, an object in most cases, if you've dealt with Kubernetes, you know it as a YAML file. But really what that is, it's a persistent entity, right? A piece of data that gets stored in etcd in this case. That Kubernetes uses to represent the state of something. So the state of something could be a system resource, a container, a containerized application in a pod, a node, right? It's basically describing what type of resource is actually within Kubernetes. It's a record in sense, and because it's a record, a lot of times these objects are used as sort of a way to describe intent, right? I'm going to create an object that describes a piece of a pod or a container or a piece of storage. I'm going to send it to Kubernetes, and it's going to have to figure out what I'm describing in there based on a set of standards. And we if you ever look at the top of a YAML file, there's usually an API version and things like that. And based on those versions, it'll say, oh, this is what this object wants to do. So then it will go ahead and eventually create that resource in the cluster. And that's sort of what we call a little bit of eventual consistency, is that you kind of send it off and then it does its thing to get to a desired state. So just think about an object as a way of describing something that gets you to your desired state. I think if I were to boil it down into maybe a sentence, that would be how I would describe it. What about you, Bhavin?
Yeah, I like your description, right? It's a record of intent that once you specify it using a YAML file, Kubernetes scheduler will always check the spec for that object and use its reconciliation loop to make sure that the status matches the spec. So In addition to API version, you specify things like the kind of object, the metadata,
Yes.
so you can give it a name. If you want to restrict it to a specific namespace, you can specify that too. And then specification or the spec section is where you provide those additional level of details that are used as the desired state for your Kubernetes object. So Kubernetes objects, everything that we talk about in our day-to-day lives, in all of our podcast episodes, from pods to storage classes to volumes to deployments and etc. All of those are, end of the day, just Kubernetes objects. So that's a good 101.
Yeah, absolutely. And those big things you want to look at in each one of these files is that API version, the kind, as you mentioned, because kind is a really good one to look at because it really gives you the object you're trying to create, right? It's a service, it's a deployment, it's a pod, right? That'll be the kind. And then there's the metadata, namespace, and spec. Spec, obviously, the spec's so vastly different between every object that it's that's the place to really dig in once you know what kind of object you're going to really create. So that hopefully gives you a sense of what a Kubernetes object is, and what we're going to focus on today is workload resources, because for the most part, workload resources or workload objects, I'll call them, in Kubernetes are the things that consume storage. And the reason being is because what consumes storage? Workloads, right? I think that's pretty straightforward. At least when I read through this from the second time, we kind of use these as second nature, but looking through all the Kubernetes documentation, this all comes together. So workload resources are pretty much anything that runs some sort of compute and has the ability to consume storage. It doesn't have to, right? For instance, I think the most basic object I think we can talk about first is a pod in terms of workload objects. And that pod is really a core unit of understanding Kubernetes, and it's a collection of containers. So if you know what containers are, or if you're familiar with Docker, that Docker container runs an application, well, a pod can actually run many containers, right?
Yeah, it's like an atom. Like pod is atom, and then you can have your electrons and neutrons and everything. So those are different containers that are part of the atom. It's like the smallest divisible unit in Kubernetes.
Exactly. And each one of those containers in the pod spec, right, we talked about, pod being the kind in this case, the pod spec being the spec that's needed to define what a pod is. Each container can have a number of different things. We're not going to go into every one, but one of those sections is volumes. So volumes, again, is many things in Kubernetes, right? If we dive into what a volume is in Kubernetes, we talk about persistent volumes, mostly on this show. Maybe some bit of host volumes, but Kubernetes defines many types of volumes, right? Persistent volumes, projected volumes, something I was just talking to Bhavin about. I've never used before, but it's something really cool. Projected volumes is a way to map several existing volume sources into one directory. So
interesting.
You can have like a secret, a config map, a downward API, a service token even, and just put it into one directory, which, it only supports a certain amount of those today. I think those 4. But if you think about the capability that really is driving at, it's super cool.
If anybody from our audience is using those, please hit me up. I want to learn more about this. I'm just how are you using this? I just want to know more.
Absolutely. Yeah, these are all really good. And we won't go to everyone's, but there's ephemeral volumes. And then, we'll mostly host volumes, those kind of things. We'll mostly talk about persistent volumes. So and when we say that is, on our 101 episode for storage in Kubernetes, it really talks about storage provisioners that have some type of provisioner and storage class that provision PVCs and PVs. That's really what we'll focus on. But again, right, pod can have volumes, and that volume can be many things. But again, it's a object in Kubernetes, probably the most straightforward and base unit that you can think of that consumes storage. I would say the other one I have on the list here that's sort of at that level is a job, right? So a job is really, it also runs a pod, or at least a container, right? I think it might actually run Yeah, so a job spec has a pod template spec. So putting these two together, a job is actually something that runs a pod, which runs a container that does something, right? The difference is that jobs are typically run as cron jobs, a collection of jobs, one-off, right? They're not longer-lived types of compute resources, but a job may need some kind of external information that's stored in a volume. And can consume a volume as well. And I think, that's just another level of type of resource. Again, this would be a kind of job, right?
Yep.
And I believe in that job template spec, you have the full gamut of volumes available to be used, but I'll have to double check that. So, those are base units. I think what we need to now go into is, okay, a pod is great because it's a single thing and may run multiple containers, but how do you combine many pods, right? We talk about distributed databases. We talk about, other types of applications that have multiple containers. How do you coordinate those, right? And this is where something like deployment and StatefulSet comes in. So I'll let you jump into that.
Yeah. So as you said, right, like pod does one thing really well, but then when you're running distributed applications, if you need multiple replicas, if you want to change between different versions, all of those are made simple. All those operations are made simple by using a deployment object. So similar to how you described a job has a pod spec, deployment has a pod spec too. So when you create a deployment object, it will actually to do the actual work. It will create pods in the background using another layer of abstraction called replica sets. But deployments not just help you define how many replicas you need for a specific pod. So you can have a MySQL instance with a primary and a secondary node, part of a deployment or a stateful set for that matter. You can have different versions. So if you have an application that's running V1, by using a deployment object, you can upgrade it to a version 2, and you can have an upgrade policy, whether you want to, how much downtime or how many pods can you take down to upgrade to the new version. All of that you can specify as part of the deployment specification. And again, since it uses pods under the covers, you can still attach persistent volumes and dynamically provision those to store any data that the pod might generate.
Yeah. And that's a good point, right? Deployment, you might be asking yourself, why use the deployment instead of a pod, right? And that those are key points in saying that orchestrating many pods is a replica set. Now, we're not talking about replica sets by themselves. So they don't really use storage. Technically, they just have multiple pods and they orchestrate those. But then the deployment allows you to kind of declare and manage updates across all those replica sets and the pods within them. And so it really adds to the orchestration and behavior capabilities of Kubernetes of managing an application. And I would say in most cases, if you're using Kubernetes for the first time, a deployment spec is a really good way to start, right?
Yeah.
If you create a pod, you create a pod spec, but it's probably not the most common way to run an application because it's sort of a one-off. It's more of a you have to manage certain things about it, which is a little more difficult. But deployment spec, I think, is probably a really good way to start. And within that, within deployment spec, there's the pod template spec, right? Which basically is a pod spec. So if you're familiar with one, you basically can put those within there, and those is where you define all those volumes and PVCs and those kind of things within them. And in those deployment specs, where you define the volumes, often it'll reference what persistent volume claim to use, and this is important because you're not really defining you're not saying the storage class to provision the volume in there, right? Usually the provisioning of the volume itself is done through a different set of YAML files and objects, right? Which is the storage class, the PV, and the PVC. In the deployment, you'll just reference basically the name of that PVC and the mount points and things like that, which slightly differs from how StatefulSet does it. and that's the reason I'm bringing it up now. So if you're familiar with the PVC and StatefulSet and storage class kind of workflow, right? You create a storage class, you have a PVC that references the storage class, and then the PV gets created as the physical thing from the PVC that references the storage class. Big old full circle there. And we won't go into depth because we did cover this in an earlier episode. Definitely go take a look to that if you want to dig into that. But the next one we're going to talk about is StatefulSet, which is, I would call an evolution of people using stateful things on Kubernetes. What would you say?
Yeah, definitely. Like when you're deploying those distributed databases, you need the master nodes and the worker nodes to come up in a specific order and always have those entities associated, or identities, not entities, identities associated with those. And stateful set is how you do it. So the first pod will always be a -0 or a master. And once that comes up and is fully online, that's when the other worker nodes or secondary nodes for that database are brought online. So stateful set helps you always maintain an order when it comes to deploying your distributed databases.
Yeah, and this is right. This and the reason I called it an evolution before is exactly because of that. Because people were, orchestrating complicated and complex stateful things that needed some kind of order associated with them. This pod comes up first, then this one comes up second, and talks to the first one, and those kind of things. Where an example would be a seed node in a Cassandra ring. And they needed more from stateful components, and so StatefulSet came to be to create that order fidelity and extra orchestration. Now, in that object, there is something called a volume claim templates list, which is basically a list of PVCs. So the difference in this case is actually in the StatefulSet, you'll reference, create these volumes based on the storage class. So storage doesn't have to pre-exist. You don't have to have a separate YAML file for the storage class of the PVC in your set of objects. It can just be right in there to say provision this type of volume, this size, and everything from this storage class right in your StatefulSet. And it actually streamlines the process pretty well. Now you'll still have to definitely take into consideration what that storage class is doing. In terms of retaining things on deletion, etc. We talked about this in 123. There's some new capabilities around that because stateful sets are their own beast. You'll definitely have to practice with them and get to know how they manage the storage and what expectations they have. Because I also believe stateful sets by default try to put a pod on individual nodes, if I remember correctly as well, just because of the nature of them. But I don't think they have to.
I think we can use affinity and anti-affinity rules to enforce that. But again, that's something that you can add to your specification, and Kubernetes will provision those pods on different nodes if that's what you want, or on the same node if that's what you want.
Exactly. So a step I would say in a similar direction is something called a DaemonSet. Right? We have a StatefulSet and DaemonSet. I wanted to mention this because DaemonSet, while they often don't reference PVCs and storage in a way, they do have the capability to define volumes, right? And the reason being is because a DaemonSet, in its name, it's typically used to run a daemon on a node, something like cron or DNS or timesync or whatever, those types of tools. Even many of the cloud native storage providers run their own software as a DaemonSet because it has to run on every worker node. So you have a DaemonSet defined on every worker node, run the same thing on every worker node. That way, if it scales, your whole Kubernetes scales, it'll just add a pod to that replica set as a daemon. Now, would you want to use PVCs in a DaemonSet? I personally don't have experience with it, but it is capable of doing that and using volumes. I think more common to a DaemonSet, because it is a daemon on the host typically, is that it defines volumes like host paths and things like that to say, look in this place on every node because there's some system process configuration there or something like that. So maybe honorable mention DaemonSet here. I did read into this specifically. I was like, can you actually define PVC? Yeah, you absolutely can. So, and that I think is the way some providers like I believe even Ceph and Rook define like PVCs in their OSDs and things like that. But pretty interesting stuff. So I think that's the list, right? As a recap, we had workload resources, and those were pods, jobs, deployments, StatefulSets, and DaemonSets. And that we covered as basically the main ones you really want to dig into that use storage and volumes. And I know that we had a note here to talk about a little bit about storage classes. So do you want to jump into that before we, move on?
Sure. Again, as Ryan said, right, we have covered the whole logic about how you can dynamically provision persistent volumes using storage classes and persistent volume claims. And then your pods can actually use the PVs or persistent volumes that have been provisioned. We just wanted, since this is a 101 episode, we wanted to cover the different things that you can specify as part of a storage class definition and a persistent volume claim definition, and what those different terms actually mean. So similar to how a pod has the API version, metadata, spec sections, all of those still apply here. But for a storage class, you can specify additional things like a provisioner. So a provisioner is nothing but a way to specify which volume plugin to use to provision a persistent volume. So this can be Amazon EBS, it can be Google Cloud Persistent Disk, it can also be Portworx for that matter, and that's the name of the provisioner. You also have things like reclaim policy. So reclaim policy is what happens when the persistent volume is deleted. Do we retain the PVC or we delete it? And like by default, you can set a specific thing. But again, that's something that you can specify as well. In addition to it, you can also specify a volume binding mode. And there are two options for this. One is immediate. So as soon as a PVC object is created, a persistent volume is provisioned, and it doesn't take into account any pod constraints like node affinity, anti-affinity, all of those rules. Whereas some of the provisioners do allow you to specify wait for first consumer as the volume binding mode, and this is where your pod gets scheduled first based on the resource requirements, the node requirements, and then a persistent volume is provisioned accordingly and attached to the pod. So different settings that you can play around with as part of a storage class definition. And then finally, you have the parameters section, which will differ for each vendor that's providing storage for Kubernetes. For Portworx, for example, we have things like the type of file system you want, the number of replicas you want to store, whether you want a different IO priority and IO profile, snapshot schedule, whether you want it to be a shared V4 volume or not. So the addition, like you can, each vendor can provide its additional parameters or additional offerings using the parameters section, and you as the administrator can go ahead and configure the storage class and have these defined. So whenever a PV is being asked for, a PVC is being created, it will inherit all of these different settings that you have configured as part of the storage class definition. And like that's it for storage class. For persistent volume claim, again, in addition to API version, kind, and metadata, you can specify additional things in the spec section, which is access mode. So whether you want a read write once or read write many volume, a file or a block, the resource request. So how much storage do you actually want? The name of the storage class, again, you can link it back to a storage class that has been deployed or defined by your administrator. If you don't specify a name, the default storage class for your cluster will be used. So you'll still get storage if a default class is configured, but you won't get a storage that you might actually like need for a specific type. And then that's how, like, if you are not using storage class for provisioning or dynamically provisioning volumes, if this is a PV that has been pre-provisioned by administrator and you are just using a PVC object, you can have selectors as well that point to the pre-created PV. So those are all the different settings that you can play around with when you're dealing with storage classes and persistent volume claims. And with that, I think we're ready to wrap.
Yeah, I think so. I think we covered a lot there, right? So as a real kind of quick takeaway here, definitely learn what an object is in Kubernetes, that it's, a record of intent for a desired state, and those objects have various use cases, workload resources, or workload objects we talked about today are typical to the ones that consume storage, that being pod, job, deployment, StatefulSet, DaemonSet. And some of those can use various types of volumes. Some of them can use storage classes that produce volumes they can use. And storage classes and PVCs and everything have their own sort of, types of parameters to consider about what type of storage is actually given to those workload resources. And yeah, I think that's a good summary of what objects use storage.
I know, like it's good to go back to school sometime and cover these 101 topics because we definitely get questions, right, as part of our day job. And even listeners to this episode have reached out to us and asked about like doing more 101 content. So when we are not talking to guests or covering any specific recaps from events, we'll definitely spend more time on similar topics and then dive deeper into some of these 101 things that we often overlook. So I'm excited to doing more of these in the future.
Yeah, me too. Speaking of which, this is the last episode of 2021 I mentioned earlier. We will be back in January, early January, with our first episode of season 2. I think we're slated to dive into Tanzu again.
Yes.
But I hope everyone who has been listening, first off, thank you. And secondly, definitely go ahead and message us, review us. Let us know, what you thought of season 1. What do you want to hear for season 2? What did you like? What didn't you like? Send it all. We want to hear it. We're here to really dive into more in the cloud native storage ecosystem, and we're excited for season 2.
Yeah, happy holidays, everyone. And if you meet somebody in the infrastructure or Kubernetes ecosystem, share this podcast with them. That's one call to action I have.
Thank you for listening to the Kubernetes Bytes podcast.